Hi students, small request Nana. Without subscribing my channel, you are watching my videos students. Please subscribe my channel Nana. Please support me. Then I can do more videos students. Please Nana, please subscribe. Please. Okay, thank you students. So in today's session, I'm going to discuss about Neet 2022 chemistry question paper detailed analysis Nana. Okay, na this exam conducted on Sunday 4th September 2022 students. This is the day 1 class. Okay, so every day I will take three bits Nana. I will discuss. This is day 1. This is starting class Neet 2022 chemistry question paper discussion. Okay, day 1 class. So question number 51. The correct order of bond angles in the following compounds is bond angles in the following compounds. Here four options given. Which is the correct answer is asking students. Here trick box. What is a trick box? Bond angle is directly proportional to the percentage of S character, and second one is bond angle is directly proportional to the 1 by number of lone pairs Nana. If suppose hybridization, four compounds hybridization is different, then you have to follow first trick Nana. Trick number 1. If suppose hybridization is same, okay, any 2 3 compounds, okay, hybridization is same, you have to follow the second trick. Okay, now trick number 2 you have to follow students. If hybridization is same, then you have to follow trick number 2. If hybridization is different for 4 compounds, you have to follow trick number 1. Are you clear students? Clear? This is same. Here hybridization is different. Are you clear? If hybridization is different, hybridization is different, you have to follow the trick number 1. Are you clear? This is the trick number 1. This is trick number 2. Are you clear students? Trick number 2. Okay, now see here, 4 compounds given. First I am going to calculate, because I don't know what are their hybridizations. So first I am going to calculate the hybridization. If their hybridizations are different, then I will apply trick number 1. If hybridizations are same, then I will apply second trick Nana. Okay, now I'm going to calculate the hybridization. So here 4 compounds given students. Solution: 4 compounds given. First one is water. Okay, so water. First I'm going to calculate the hybridization of water. 4 compounds here. Okay, water I'm taking. Now how to find the hybridization students? How to find hydrogen valence electrons? How many Nana? Hydrogen 1 valence electrons, 2 atoms are there. That's a 2 valence electrons, plus oxygen valence electrons, 6 valence electrons. Correct? Total 8 valence electrons. So if suppose valence electrons number is the total number of valence electrons, here I am giving the one more trick for the hybridization. Total number of valence electrons is equal to 8 or less than 8. Total number of valence electrons equal to 8 or less than 8, then should divide with Nana. This value, total number of valence electrons, should divide with 2 Nana. Are you clear? So we should divide with 2. So suppose x by 2. That means x is the number of valence electrons, should divide with 2 Nana. If suppose the total number of valence electrons greater than 8, if it is greater than 8, total number of valence electrons, if it is equal to greater than 8, then we should divide with Nana 8 Nana. So that number you have to divide with 8. Okay na? So this is the trick. Here I am writing full sentence. Total number of valence electrons. Okay, so in hybridization you have to remember this trick Nana. Okay, so then you can easily calculate students. This is the trick to calculate the hybridization. Okay, right. Now see students, I am going to calculate the water. So hydrogen valence electrons 2, oxygen 6 valence electrons, total 8 came. So if it is equal to 8 now, so that's why this number we should divide with 2. So I am going to divide with 2 Nana, then you will get 4. 4 nothing but which hybridization students? sp3 hybridization. Correct? See here, 2 means which hybridization? sp hybridization. Okay, 2 means sp hybridization, 3 means sp2, 4 means sp3 hybridization. Clear? sp3 hybridization. Right now, water completed sp3 hybridization. So here, what is the s character, students? What is the s character? How to find it? S character, s percentage, s1 there. Total how many? S1 p3 total 4 into 100, then you will get 25%. S character how much, students? 25% s character is present in the water. Okay, next I'm going to calculate the second option. Okay, NH3 molecule. Second molecule NH3. I'm going to calculate hybridization, Nana. NH3 hybridization I'm going to calculate. See here. Nitrogen valence electrons 5, hydrogen valence electron 1, total 3 atoms are there, 5 plus 3, 8 by, it is equal to 8, so that's why we have to divide with, according to the trick, equal to 8 means the total number of valence electrons should divide with 2, so that's why you have to divide with 2, you will get 4, means sp3 hybridization. Here also s character how much, students? S percentage 25%. Are you clear? S character 25% is there. And coming to the third compound, NH4 plus I am taking. Now, how to find the hybridization of NH4 plus? Nitrogen valence electrons 5, hydrogen valence electrons 1, but here 4 atoms are there. Take here 4 and charge plus 1 is there. You have to subtract minus 1. Plus indicates loss, so you have to subtract. Then you will get the 5 plus 3 is equal to 8. 8 by 2, again 4 you will get. That means sp3 hybridization. Here also s character how much, students? S character is 25%. Are you understanding? S character 25%. Okay. Now fourth option also I'm going to calculate. What is the fourth compound? CO2. Okay. Now 4 compounds given like this. Okay. Fourth also I'm going to calculate. CO2. So here carbon valence electrons 4, oxygen valence electron 6, but 2 atoms are there, 12, 16, total 16. It is greater than 8, so that's why it is greater than 8 means the total number of valence electrons should divide with 8. So that's why this value we are dividing with 8, then 8 2s are 16, 2 means sp hybridization. Here s character, in sp hybridization s character is 50%. Okay, now trick number 1. What is the trick number 1? Bond angles directly proportional to the percentage of s character. Now if you see first, second, third, 3 compounds, students, these 3 s character is same only there. Okay, na s character 25%, hybridization same, sp3 hybridization, see here hybridization also same only, sp3 here also sp3, here also sp3, same sp3 hybridization there, same character. So sp3 same, if hybridization same now, so that's why we have to go for second trick. Are you understanding, students? Because hybridization for 3 compounds same there. If it is different, then directly we can see. And here fourth option CO2, it is having the more percentage s character, correct? 50% is there. That's why here CO2 compound is having the more bond angle, students, because s character is more. According to the trick number 1, s character is more, then bond angle is more. So that's a CO2 s character 50% we got, so that's why bond angle also will be more, students. Okay, now remaining 3 I'm going to calculate the second trick, Nana. Bond angle is directly proportional to the 1 by number of lone pairs. So first I'm going to calculate the lone pairs. Okay, first 3 compounds all I'm going to calculate lone pairs. Water, first one. Lone pairs I'm going to calculate. Lone pairs. Okay, now see, students, lone pairs, how to find it? Which one? First, water molecule. So how many lone pairs are there? See here, oxygen valence electrons, how many, students? First of all, how many bond pairs here? 2 bond pairs. Oxygen valence electrons, 6 valence electrons. So I'm going to calculate the lone pair. 6 valence electrons minus number of bond pairs, then you will get 4 electrons is nothing but 2 lone pairs. Okay, so like this you have to find how many hydrogens attached to the central atom. 2, that is the bond pair. Lone pair, how to find it? Oxygen valence electrons minus bond pairs, then you will get the number of electrons. 4 electrons means 2 lone pairs. Suppose 2 electrons came means 1 lone pair. Are you understanding? Pair is nothing but 2 electrons, na? So 4 electrons we got, that means 2 lone pairs. Now coming to the next compound, NH3. NH3. See, students, NH3, nitrogen valence electrons sorry, how many bond pairs, Nana? How many bond pairs? 3. How many lone pairs? How to find it? Nitrogen valence electrons 5, bond pairs 3. That means 2 electrons. Nothing but one lone pair. Is it correct? One lone pair we got. Understanding? So here in water we got 2 lone pairs. In ammonia, how many lone pairs we got? One lone pair we got. Okay, now next third compound, if you see NH4 plus, third compound NH4 plus. Now see here, NH4 plus. How many bond pairs? 4. 4 bond pairs are there. Now coming to the valence electrons of nitrogen, total 5 valence electrons. Here plus 1 is there, last 4. 4 minus 4, that means 0. No lone pairs, students. Are you clear? 0 lone pairs in the case of NH4 plus. Okay, na? So here what is the trick number 2, students? Bond angle is directly proportional to the 1 by number of lone pairs, or inversely proportional also we can say. Okay, now so that means here number of lone pairs are more. Number of lone pairs more means bond angle is less. Are you clear? So here in which order is asking, students? Increasing order is asking. Increasing order means what? Small to big. Small to big is asking. Small to big is nothing but bond angle. Which one is having small? Lone pairs more there means bond angle is small. So lone pairs more, which is having water. Next NH3 is having. Next NH4 plus. And fourth one, because of S character more na, that's why it is having more. So that's why what is the option correct one? Tell me, students. First one, water. Water is having the more water is having more lone pairs, that's why its bond angle is less. Next NH3 is having one lone pair, that's why its bond angle is less, so NH3. Next which compound? NH4 plus. Next which one? CO2. So this is the correct option. Are you clear, students? This is because of S character 50%, that's why its bond angle is more. Remaining 3 we used trick number 2. Are you clear, students? We have to calculate the lone pairs of electrons. So this is the trick box, students. You have to practice these two tricks, Nana. If hybridization is different for 4 compounds, you have to follow this trick number 1. Bond angle is directly proportional to the percentage of S character. It's nothing but you have to find the hybridization, then you can easily find S character. Bond angle is directly proportional to 1 by number of lone pairs, or bond angle is inversely proportional to the number of lone pairs. If hybridization is same, you have to follow the trick number 2. Are you clear? So this is about the first question, students. Clear? Now coming to the, so which option is correct? First option is correct. Okay, first option is correct. Now coming to the 52 question. See here, 52nd question. KH values for same gases, values for some gases at the same temperature T are, here gases given, KH values given, students, where KH is the Henry's law constant in water. That means solubility given, students. These gases are soluble in water. Their solubility in water values given. Henry's law constants values given. So here 4 options given, students, which is the correct answer. So here also you have to remember trick box. Value of KH is directly proportional to the, what is the directly proportional to the 1 by gas. The gas is solubility in water, students. Okay, now you have to practice this one. This trick box, Henry's law constant. Now see, KH value which is having the more, okay, now here KH value which is having the more, that is having the that gas solubility is less in water. Are you understanding? So here which is having more, students, here also increasing order given. Increasing order given means what? Small to big. Small to big. Small to big is nothing but here argon. Here see the value of KH value should be less. Okay, now so if it should be less, solubility in water, 1 by gas solubility in water. So here how to take so here 40.3 KH value is more, so greater the value of KH, solubility is less. Are you understanding? So solubility is less, so it is having the more KH value. Argon is having the more KH value, so that means it is having the its solubility in water is less, so that's why argon solubility is less. Okay, now after this which value is more, students? Which value is more? This value is more, 1.67. Yes, so that means CO2 solubility in water is this one, it is less. Are you clear? When compared to argon, the solubility is more. And coming to here, these two options, which is more, students? 0.413, CH4 is more. Okay, because here 10 power minus 5 is there now, so you will get the very very small value. So 0.413 will get, it is having the more value, so that's why CH4 solubility in water it is more. And coming to the last, a KH value is very less, that's why solubility of formaldehyde in water it is more. Are you understanding? So that's why option 1 is the correct answer. Are you clear? So KH value is more, the gases solubility in water is less, students. Are you clear? So here they're asking in water, so KH of the Henry's loss constant in water is, so here the gases solubility in water is asking, so option 1 is the correct answer. Are you clear? Next, 53rd question, students. 53rd. See here. Which of the following reactions is a part of the large scale industrial preparation of nitric acid? Nitric acid. Here four options given, students. Large scale industrial preparation of nitric acid. Which method? Ostwald's method. Now, so we know that Ostwald's method, these are the three reactions taking place. Correct? 4 NH3 plus 5O2, 4 NO plus 6 water. These are the conditions same only. Okay, platinum is a catalyst, 500 Kelvin temperature, pressure 9 bar. Okay, produces NO6 water. It is a second step. NO, nitric oxide, when dissolved in when it is treated with oxygen, produces nitrogen dioxide. Nitrogen dioxide when dissolved in water produces HNO3. So this is the Ostwald's method, manufacturing method, large scale industrial preparation method. So that's why here in these four options, which is the correct answer? Ostwald's process for the formation of nitric acid, second option, because this is the reaction, first reaction. Are you clear? So option 2 is the correct answer, students. Are you clear, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Nana. Thank you, students.